Example 6, 6b, we've got tangent A plus B, and that should, that forces you to look at your formula sheet. I've got tangent sum, and that tangent sum formula says tangent of the first one plus tangent of the second one over 1 minus tangent of the first one times tangent of the second one. There's my formula. So then I've got 4 holes to fill in. So this is very similar to part A. I'm just using a different identity. I'm using the tangent identity instead of the sine identity. But the problem didn't seem to give you any of that information. It didn't give you any of those tangent values. But if you look back at your picture, it's pretty easy to figure out from your picture. When we look at angle A and this triangle right here, all we have to do is find tangent A, and I can do that from this picture because I know tangent A is y over x. And so just look at this picture and look at y over x, 4 over negative 3. That's tangent A. Opposite over adjacent, if you will. But tangent A is negative 4/3. And so in your formula, you should be able to fill out tangent A as negative 4/3 in that expression. And so what else do we need? Tangent B. Look at your picture. Okay, look at your picture. And here's angle B, or here's your triangle. And so if we want tangent B, again, that's y over x. That's going to be negative 12/5 or positive 12/5 if we do y over x. Y over x, or opposite over adjacent. So tangent B is going to be 12/5. I've got the 4 holes filled in. I just need to do some algebra to clean this up. And maybe that's the hard part. I don't know. But look what we have. We have negative 4/3 plus 12/5 over 1 plus 48 over 15. Clean up that fraction down at the bottom. You can multiply it 4/3 times 12/5. And as always, when we add fractions, we want a common denominator. So let's get a common denominator. So over here, I'm going to multiply by 5 over 5, and here I'm going to multiply by 3 over 3. So that I'm looking at negative 20/15 plus 36/15. And on the bottom, 1 plus 48 over 15, let's just call this 15 over 15. I'd have 15/15 plus 48/15 is 63/15. And so cleaning up the fractions, negative 20 plus 36 is 16. I have 16/15 over 63/15. And at some point, hopefully, you notice that those 15s are just going to cancel out. Okay? I know the 15s are going to cancel out, and hopefully you do too, but if you don't remember that, you're dividing fractions, and so let's multiply by the reciprocal. That makes it a little bit more obvious why the 15s cancel out, but we're going to get 16 over 63. So we wanted to know tangent A plus B. Tangent A plus B equals 16 over 63. So then the last question should be the easiest question. I find students struggle with it a little bit because it's not quite obvious what you're going to do. But they want to know the quadrant of A plus B. Not the quadrant of angle A, not the quadrant of angle B, but the quadrant of what you'd have if you added those two angles together. What quadrant would we be if we added those two angles together? Okay. Well, let's recall what we got in part A. Sine of that angle sum was 16/65. So we had sine of A plus B equaled 16/65. And then what we just found in part B of our question was tangent A plus B equals 16/63. Okay. What's noteworthy is that both of those values are positive. Sine of that angle sum is positive, and tangent of that angle sum is positive. So if you look at where sine is positive, we know sine is positive in the first or second quadrant. And if you look at where tangent is positive, tangent is positive in the first and the third quadrants. And so you put those two things together. We know that sine is positive and tangent is positive. Well, there's only one quadrant where that can both be true. Both of those things are true in the first quadrant. And so we know that sine and tangent are both positive in the first quadrant. That's our answer. Quadrant 1.